All right, we're back for part 2. So we want to take the limit as x approaches -4 from the left. So as we approach -4, again, from the left, we're approaching from the left. What is my y value approaching? 2. See, I'm approaching 2. If we approach -4 from the right now, so now I'm on this part, and I'm approaching -4, I'm approaching, my y value is approaching 3. So now we're looking, does the actual exist? Now we're going to be more formal for our definition. They're not equal. The left and the right don't equal, so we would say D and E does not exist. And what's the reason? And here's what we have to write, and I want to see you write this. You have to write this, because in calculus, if you don't write this, you miss the entire question. We would say because the limit as x approaches -4 from the left of our function does not equal the limit as x approaches -4 from the right of our function. And that's the entire answer. And then for 4, what's the value at -4? That's easy. Look for the dot. It's 2. So let's try number 5 down here. Now, notice for this one, it's looking at the actual value. So, to look at the actual value at 3, if I want to find the limit as x approaches 3, the only thing we know for the actual limit to exist, for it to exist, we know this, that the left must equal the right. And if I'm approaching 3, here's the left, here's the right. Are they approaching the same number? Yes, they are. So it's -2. And the reason for that is because the limit as x approaches 3 from the left equals the limit as x approaches 3 from the right of our function. And there's our answer right there. Now, what's the actual value at 3? -3. We're going to talk about that in just a few moments, okay? So does the limit equal the value? No. That's what we're going to talk about. All right, for number 7, what's the value as x approaches, what is the limit as x approaches -2 from the right? So as I approach -2 from the right, here's -2, as we approach from the right side, excuse me, what are we approaching? My y value, as I'm approaching -2, my y value also approaches -2. What happens as x approaches 6 from the left? Well, here's 6. Here's the left. There's my L. I'll go up. What are we approaching? It looks like 1. Very easy to do. All right, so let's take a look at number 9 here. Now, number 9, it says name 2 x values where the function is not continuous. So a couple of things have to happen here. One, we're looking for a value, and we're looking for a limit, and we're looking for them to not equal each other. The obvious is x equals 3. Okay, and that's because the limit, which equals, we said -2, does not equal the value, which we said was -3. So the limit does not equal the value, and that's what we're looking for right there. Now, another harder one, where else is it not continuous? And graphically, it's easy to look at. It's at -4. It's not continuous. I have to stop. I have to take a break before I continue drawing. So at -4. But the reason why isn't because the limit doesn't equal the value, but it's because the function is not, the limit itself does not exist. And that's what we say here. The limit does not exist. So let's try -3. Let's try number 10 here. Does the limit exist at -3? Why or why not? So let's take a look. At -3, now they don't give me a point, but there is one right here. The first thing I'm going to do is I'm going to look at the limit. Well, what's the limit as x approaches -3? And this is how we write it. That's easy. Well, from the left, I'm approaching the same number from the right. They're approaching the same place. Look for that car crash. And not perfect, but it might be about what, 0.1 you think? Next, we have to look at the value. Well, what's the value at negative 3? Well, right here, it's the same exact point, so it's 0.1. Are these equal? Yes. Therefore, we could say, oh, we didn't want no continuous, we just want to find the limit existing. So, wow, so we didn't have to do the value, we just have to look at the limit. So so we can say, therefore, the limit does exist at x equals negative 3. Why is that? And let's go for a formal definition now. The limit from the left equals the limit from the right, and that's what we put. The limit as x approaches negative 3 from the left equal the limit as x approaches negative 3 from the right. And there's our reason. It's kind of a lengthy reason, but that's why we don't have to do these too much. All right, now that's the end of the notes. Be prepared. You might have a pop quiz tomorrow on trig values. Good luck. I'll see you tomorrow. Bye.